we'll have a quick overview of what joins are and how join the concept behind the joins. We have joins where we try to combine two or more tables or two or more relations to create an virtual table and to work on it. Suppose, for example, you have employee ID and the department ID. You also have the department name. If I have to combine the employees along with the department, why should I combine it? Because I have already separated it in order to avoid redundancy. So I try to combine it and work with things. You go for a join operation. We also go in for an Cartesian product where every other row of the first table is combined with every other row of the second table. So that is what is a Cartesian product. A Cartesian product is formed when there is no condition on join. You simply combine it, or if the condition, even if the condition is invalid, it doesn't give you any logical meaning, you try to combine all the rows. Now in a Cartesian product, if I try to add some where clause condition to it, then it becomes a valid join condition. So now here, a simple example of Cartesian product, you take in 20 rows of the first table, you take 8 rows of the second table, and the output on Cartesian product would be 160 rows. How do I do it? You just say select star from employees, comma, departments, and will give you the Cartesian product of it. And this is what is used here. Select table, you just, instead of using star, I can say table 1's column name and table 2's column name. From table 1 and table 2, table 1 comma table 2 will build the Cartesian product. Now since I am enforcing the column 1, table 1's column 1 value has to be equal to table 2's column 2 value, then you force and join operation to happen. Now there can be n number of names. Maybe the first name can appear in the employees table, as well as first name can appear in the instructor table. So to avoid ambiguous names, it's preferable to use the table name dot the column name. So instead of saying employee ID, I'll say employees dot employee ID, employees dot last name, and so on. But now using a lengthy relational name makes the complete query very lengthy, and the table name is repeated again and again. So to avoid it, you go in for the alias name. So what do I do here is we say employees has an alias name as E. Instead of employees, I can use E. And instead of departments, I can use D. So wherever I try to pull in employee, you say E dot employees ID, E dot last name, which what does E refer to? E refers to the relation employee or the table employee. Fine. And wherever once you have used the alias name in the from class, wherever you want to use employee table name, it can be replaced with its alias name. Now, what do I do here is to join 3 different tables. The first 2 tables are joined based on the department ID. And the second and the third table is combined using the location ID. And what is self-join? You also have another condition where the previous example, what we took in the previous slide, is to combine 3 different tables based on a condition. Maybe you say select the last name, department ID, location ID, and city from 3 different tables where employee.department ID is equal to department.department ID, and department's location ID will be equal to location's location ID. So when those 2 conditions get valid, you try to combine the first table, second table, and the information from the third table. I can also overlap a single table and reflect it. Now, for example, I have an employee table where you have manager's information as well as the workers' information. Now, if I have to pull out all the workers who work under a particular manager, then I go in for a self-join. Self-join is you take one table and combine it twice with itself. So now what happens? The manager ID is taken. Maybe the manager ID starts from 100, so it is taken, and you try to pull out the name of it and the worker's name who are come under that particular manager. So now here you have a joining table to itself, which you call it a self join, where you say select worker's last name. You concatenate it, works for manager's last name. Now I have given two different allies name. The same employee relation is being termed as worker, and it has also been named as manager. And then you say worker's manager ID and manager's employee ID has to be equal. Now, where does it happen? Here you have an employee ID as well as a manager ID. So you try to take these two and pull it out. You have something called as cross join. Cross join is similar to your Cartesian product, but then you use the term called as cross join. It is another keyword which is used. It produces the cross product of two different tables which you have in. Now the next one is what you call it as natural join. Natural join helps us to group two different tables based on the similar column names. So for example, if I have a department as well as location, now what happens? Location ID was in common column name. If you want to just have a look at it, you can do just look at it here. You have employees, department, and location. Between location, department, and location, the common column is location ID. So this common column is used where you try to combine two different things. So you have select department ID, department name, location ID, and city from departments, where you try to pull in natural join along with location. So wherever the location ID is similar, you try to combine it. Fine, that is how a natural join works. What if instead of having a single column common to both the tables, if I have two different columns common to both the tables? For example, if I have the department name as well as the location ID common to both the tables, while I perform a natural join will work only when the two columns satisfy the condition. The department name of your departments and the location ID of your department has to be equal or similar to the department name and location ID of the locations. So when I have more than one column which has the same column name, it is always advisable to choose the column on which I can perform a natural join. So that is where I use the using clause. What does we do here? Using the using clause, you try to inform the system that even though the more than one column matches, you enforce you enforce the system to do a natural join based on the column what you choose. So now among n, I force the combination. Here you have employee and department. Employee and department has two things in common. One is the employee ID, uh, and the other one is I think you have employee ID and the department ID in common. So now what do you do here? You try to enforce the combination based on department ID alone. The rest of the columns is left without consideration. Now you also have something called as an on clause. This helps you uh, to specify certain conditions on which you can do and join, and this join is separated from other search conditions. Now for example, what happens here? You try to make a join and on the department ID you enforce the condition, whereas having you said these are the columns which you have to choose, and an on clause gives you the condition on which it has to be combined. In this case it says E dot department ID should be equal to D dot department ID. I can also say if in case of a salary, I can say employee salary should be always less than the manager's salary. So such kind of conditions can be given in order to combine the rows from the first table and the second table which you give in an join clause. Now, can I join multiple tables? Yes, I can do so. And here you have an example of having join. So we'll try to understand what this query does. It tries to pull in or project three columns from employee table. The first one is from employee table, which tries to join with the department table. So you try to pull out, and the condition is the department ID of the employee and the department ID of the department has to be equal. So you perform join, and while I perform join, the condition is the department ID has to match. Once you have it, now I have a new relation where I have performed a natural join on employee and department based on the given condition. Now that new relation will be combined with the location relation on another condition saying the location ID of both the relations has to be equal or similar. Fine. So you have a join, you also have an on clause. On clause helps you to give you the conditions for that join statement. Now you have inner join versus outer join. Inner join, we also have inner join is you try to work out with the conditions, and if the conditions get satisfied, you try to